So 4.1 is talking about graphing polynomial functions. We're going to get more into graphing polynomial functions in a little bit. So that's going to be something that we talk about just in a little while. We're not going to talk about it yet. So that being said, as we work through the graphing of polynomial functions, we need to understand something that's very, very important. The ends of a polynomial function kind of describe what's going on. So the ends of the polynomial function, when I talk about the ends, I'm talking specifically about, hang on, let me get this pulled up. I thought I filled this up. So one of the things that we really should be specifically talking about with the ends of polynomial functions are the left side and the right side. I'm talking about literally the ends of the function, like which direction the arrows are pointing on the left and the right. The stuff in the middle is stuff that we're going to be able to figure out in a little while. But right now, we are mainly talking about the ends. And the reason we're going to spend so much time talking about the ends of these things is because these are huge SAT type questions, because they can make this look really, really nasty, and they can make it a really, really tough set of questions just based on the wording that they're going to use. All right. So that being said, we are going to look at, first, we can see that we're given the equation. We're going to look at the picture, and we're going to decide what happens with these. Now, the hard part isn't going to be figuring out what direction they go, because we literally just have to look and see if it's pointing up or down, right? So that should not be a big deal. The thing that's going to make it a huge deal, the thing that's going to make it an issue, is figuring out why it does that, all right? So obviously right now we can see that the left side of this equation is going up, right? You can see that this thing is going up, so that means the left side of the equation is going up. The right side of the equation is also going up. We can see here the left side of the equation is going down. We can see the right side of the equation is going down, right? We can see that based on what these things look like. Now, that being said, we have to try and figure out why. So right here, you'll notice in the equation, it gives us a whole bunch of stuff. It says y equals 1/15 x to the 8th minus 1/3 x to the 3rd plus something. Now, it's very important to note, I don't care what this something is. I don't care what this something is, because all of the information that I need is going to be given by something that we can see. So is there anyone out there that can figure out what is making my graph go up? What is making my graph go down? Is there anyone that can figure that out? This part should be a pretty easy part. So is there anyone that can figure anything out? No one can see anything?
Well, no
On
one
the left side, you're subtracting the fractions, and on the right side, you're adding them together.
Okay, so that would be a good thought, because I have adding of fractions and subtracting of fractions. The only thing that I would argue that with, because we can see right here, I can see that I'm adding and subtracting on this side, and I'm adding and adding. And that obviously is something that that could be missed, but you're close, because you said something about adding and subtracting. So you're really, really close, just not quite there.
Is it because the fraction on the first fraction on the left side, the one with the greatest exponent, is positive, and then the other one's negative?
So exactly what was just said. The fraction with the greatest exponent is what determines this. And it doesn't even have to be a fraction. It's just the thing attached to the greatest exponent. If you notice right here, x to the 8th is the greatest exponent, and right here, x to the 6th is the greatest exponent. So whatever the thing with the greatest exponent is determines what happens to some of those behaviors, all right? So now what I'm going to do, so remember that, okay? Negative defines some of the behaviors, okay? So we're going to go through that in just a second. So now if I go back to this page, I'm going to look at, let's do this. I'm trying to find things that I can actively compare. So if I look at this one is a little bit different, because now if we look at our ends, we can see that on the first one, our ends are both going down, right? So we can see on the first one, ends are both going down. The left side is going down, the right side is going down. On this one, the left side is going up and the right side is going down. Now let's think about what's happening, because you said just a second ago, well, we have a negative, right? Or we have a positive, we have a positive. What's the difference now? Now what's the difference between these two pictures? Or between, I guess, these two equations, I should say. What could possibly make this different? And I'm going to go back here and I'm going to draw your attention to something for just 1 second. Oops, that's not what I wanted to do. So I'm going to go back here and draw your attention to something just for a second. Look at what I circled. The thing that I circled right here, the highest degree, notice what's happening to the ends. So notice what's happening to the ends. Now if we go to this one, I'll again circle the highest degree. Notice what's happening to the ends. So on this one, the ends are going both down. On this one is going up, one is going down. What could be the possible reason for that?
Is it because the one that's they're different, the exponent is odd?
That's exactly right. Okay, so we have just, so with that investigation, what I would like to have done is given you guys like 30 minutes with each other to talk about that stuff, but that's just, you know, it's a lot easier to just pop in and talk about a whole bunch of things and give one kind of general group consensus than it is to do it two on two. So this being said, we can figure out the end behavior of a polynomial function given the highest degree. So what we're going to do is we are going to look at the highest degree. I don't care what that degree is. I am just looking at the highest possible degree in this in the equation. Whatever the equation is, I look at the highest possible degree. All right. So what that means is I'm able to figure out what's happening with the right side and the left side. Now, this is something that I would have forced you guys to figure out on your own, but I'm not going to make you do that. Okay. So on the highest degree, what you're going to look at first is you're going to look at the coefficient. That means the number in the front. So you're going to look at the coefficient of that number, or of that degree. If that coefficient is positive, that means the right side will go up. So that means the right side of the equation, or the right side of the function, the graph, will go up. All right. If that leading coefficient is negative, that means the right side will go down. Okay. So in the highest degree, if I look at the coefficient, if it's positive, the right side will go up. If it's negative, the right side will go down. Notice how I'm only talking about the right side. That's because the leading coefficient determines what happens with the right side. All right. Now the highest degree, this is the actual number, and the whatever, like, so the x to a certain number, that's what we're talking about, whatever that degree is. So we look at the actual number on that thing. If that degree is even, the left goes the same direction as the right. So the left goes the same exact direction as the right one does. Okay, so if the exponent is even, the left side will do whatever the right side is doing. So you have to figure out what the right side is doing first. Then if it's even, the left side does the same thing. If it's odd, the left goes the opposite direction. So if it's odd, the left side goes the opposite. All right. So this should be something where I don't care at all what's happening with this function at all. I don't care anything about the function at all. I care about the highest degreed term, period. That's what I care about, the highest degreed term. And if all I care about is the highest degreed term, all I'm doing is looking at that first term only. And then I can figure out what's happening with the right side and the left side. Now you may ask, why is this a big deal? Why is this an issue? Why is this something that we have to do? I can type it in my calculator and see what's going on. That's totally fine. But the thing is, SAT is going to ask you in a really, really weird way. All right. So what they're going to do is they're going to ask you in a very unique way where they're going to use things like the word, they're going to use the word like approaches, and they're going to use infinities, and they're going to use x and f of x and stuff like that. So first things first, let's say that we've got an equation that looks like this. It says f of x equals negative 3x to the fifth plus 2x squared plus 1x minus 3. Whatever the equation is, I don't care. The thing that you have to try and figure out from this is what direction things go. So right now, based on what I'm seeing, is I can look at the highest degreed term, the leading coefficient, the leading term, and I don't have to worry about any of the rest of this if I'm just trying to figure out end behavior. I don't care about any of the rest of it. All right. So that being said, what I'm going to do now is figure out what happens to the right side of the equation. And what happens, or I'm sorry, of the graph, and what happens to the left side of the function. Now that being said, I just look here. The right side of the equation is determined by this, right? We can see that this thing is negative, which means that the right side is going to go down, right? And then if I look at the next part right here, this thing is odd, so it is going to go opposite of this, which means the left side will go up. So if you were to type this in your calculator, that's fine. You'd be able to see the right side goes down and the left side goes up. That's great. But the way the SAT is going to ask you this question is this, they're going to say as x approaches infinity. And then here they're going to say as x approaches negative infinity. If you think about what this thing looks like, positive infinity on a graph means as x goes to the right. Positive infinity on a number line is this way, right? Because I have all positive numbers that go this way. So positive, 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 all the way here, and then it's going to reach a positive infinity. As we go to the left, all of these numbers are going to be negative until we get to negative infinity. So the way that they're going to say this is they're going to give you a whole bunch of different multiple choice things, and they're going to make you think this is tricky and this is tricky. They're not going to give you the words left or right. They're literally going to say as x goes to negative infinity, which this means as the graph goes left. And then they're going to say as x goes to positive infinity, that means as the graph goes right. Now, obviously, if they can do that with this, they're going to do the same thing with this. But here, they're not going to use x, they're going to use f of x, because that's what the y value is. So it's f of x goes to infinity, because infinity on the y-axis is up, and then infinity on the y-axis is down. So f of x approaches negative infinity, which means down. So they're just going to start using the positive infinity, negative infinity, those kinds of ideas, instead of forcing you to just say left or right. So the way that this equation will actually look is like this. So they will say determine the end behavior or investigate the end behavior, or let's see what they're actually going to ask you. So it would say something like describe the end behavior. So describe the end behavior of negative 0.5x to the 8th minus 3x squared plus 2x plus 1. They would ask you to describe the end behavior. And then the way that things would work is they would give you a whole bunch of different things, but those different things would look like this. X approaches, f of x approaches, and then it would be x approaches, f of x approaches. And then their multiple choice questions would just be a huge combination of positive infinity, negative infinity, positive infinity, blah, 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 blah. But what you need to realize is if you know how to figure out the left side and the right side, you know how to answer this question, okay? Because if you understand the terminology of it, then you're good. As x approaches, these things right here are by and large just saying left side, right side. This thing right here is saying up or down, up or down. That's all it's asking you to do. Left, always on a number line, goes with negative infinity. Negative numbers are on the left side of a number line. So x approaching negative infinity means left. As numbers are positive, they go to the right. So positive infinity goes that way. So right side means positive infinity, left side means negative infinity. Now I just have to figure out if this is up or down. Now that being said, I'm just looking right here for that number, right? So I'm just looking there for that number. So that being said, negative 0.5 Negative means that it's going, oops, that's not the right one, because it's the right side. Negative infinity means that it's going down, or negative number means that it's going down. Down means negative infinity. So that means down. The right side of the equation is going to go down because of that number. The right side of that equation, or the left side of that equation, is determined by this. That is an even number. Even means it's going to go the same exact direction as what this thing is doing, so it will also be negative infinity, which is also down. So this is just a very fancy way of them throwing different things at you using positive and negative instead of left, right, up, down. They're saying use concepts of infinity to determine whether this thing is going left, right, up, or down. Okay? What questions do you guys have as we sit here right now? What I'm going to do instead of, we're not going to finish this today because it took a little bit longer than I wanted to kind of go through a whole bunch of stuff. So you guys are not going to have a big ideas assignment today. You guys will have a big ideas assignment tomorrow, but I'm going to throw a couple questions onto Google Classroom that I want you to try and attempt. Okay? So that is going to be it for today because I know that it's brand new right after Thanksgiving break, so I don't want to kind of overwhelm you with everything. So this is going to be the end of it. All right? If you want to stick around to ask a couple questions and go through some things, you can do that. Let me stop my recording again.